Hello, everyone. Can you all hear me okay? Great. Okay, I am Adam McNeilly. I am an Android developer in New York City, and today I'm going to be talking about GraphQL, specifically how we as Android developers can get more control over our networking APIs using GraphQL. So let me go ahead and share my screen. So pretty much just gave an intro to the talk, but this slide also has my Twitter handle on it. I'll post the slides there after the talk. If you have any questions later on, you can reach me there pretty easily. Oops. So many talks like this will start off by saying, what is GraphQL? And I think we could go into that and talk about it being this whole new networking API and talk about the nuances between GraphQL and REST. But I really think the best way to introduce GraphQL to someone is to start by explaining why we would even use it. Like, it's one thing to understand what it is, but really, as developers, we want to know, why should I care? Why should I adopt this new technology? And to demonstrate that, I want to start by looking at some existing REST APIs that we might be familiar with as Android developers, and then showing the benefits that GraphQL gives us that these ones do not. So if you've ever seen me talk before, you know that I love dealing with Pokemon as my sort of sample thing to talk about. I have this sample Pokedex app in GitHub that I'll link to at the end that I do to just try out a bunch of different technologies. So here's this open source REST Pokemon API. And we're going to look at a few different endpoints that this API offers us. The first one, if we can see by this line at the top, we just hit their URL, so hit /Pokemon, and we get back a list of Pokemon. Here we have this count of how many Pokemon we have, the key to get the next group in the pagination. But then if we look at these results, what I want you to recognize about this API is each result only gives us two properties. We have the Pokemon name and some URL to get more details about it. And now this is nice. I have a way to get all of the details, but I don't really have all the information that I want here. If I wanted to build a list of Pokemon and show their images or maybe their types all in one big recycle view, I actually can't do that with this API without making several network requests that follow to get the details. So that's one limitation we can have. On the flip side, to their detail endpoint where I do /Pokemon/name, and I'm going to get tons of information. I condensed this down just to show you a lot of the top level properties, but this API response was originally 11,000 lines of JSON. Every ability, every game that this Pokemon appears in, all of their images, their types. This is really complex, and sometimes we even still get URLs like we do here to more information. And so it's great. We have a lot of details. But again, if I were to put this into an Android app and I want to make a Pokemon detail fragment, I now have way more information than I need. So let's recap some of those problems that I just mentioned. First of all, when we're dealing with REST, responses may not have enough data. I'm glad the Pokemon examples are working. We may not have enough data. We may have too much data. But also, these responses are not controlled by the client. So in addition to those first two problems, it's that I get back whatever data the API developer thinks I need. And that may or may not be right. That's just something that we have to deal with, and we unfortunately have no control over it. And that means we aren't able to change it. If we want changes to the API responses, we have to go through another developer. So in this case, if I said the Pokemon list endpoint didn't give me enough information, I would have to go find an API developer, tell them what more information I need. They would have to make the change, get it code reviewed, merge it into master, push a new version of the API. And this process can take a long time. And me as the Android developer just have to wait it out. And that can be frustrating. So let's look at how GraphQL solves that problem. I was also able to find this open source GraphQL Pokemon API that you can go to. But we'll walk through a little bit about GraphQL syntax and then how those APIs solve the problems that we just looked at. So here's a short sample of what a GraphQL query syntax can look like. It looks similar to JSON, and then we had this Pokemon keyword here is actually a query name, and the query takes in an argument called name, which is the name of the Pokemon. And then inside that little query block, we put all of the fields that we want in the request. So to show you what that looks like, if I were to do this query at the top, I look for a Pokemon, I say the name is Bulbasaur, and then inside I say I only want the name back. The response at the bottom is going to give me the data, which has a Pokemon key, and the name is Bulbasaur. So I got back exactly what I asked for. So another example of this is I can add the number property into my query. And if we look at the response at the bottom, we can see the Pokemon came back with name Bulbasaur, number 001. So this is very exciting, right? What are the benefits that we just got here? Well, the response has just enough data because I requested just enough data. So I never have more than I need. I never have less than I need. And this response was controlled by me because I explicitly stated what I was requesting. That means if I need to change the response, if I need to add new data to this fragment or remove this text view from the fragment, I can just update the query myself. And so because I'm doing those changes, we don't have that long feedback loop that I mentioned earlier of going to another developer, waiting for them to make a change, waiting for it to be rolled out. Everything is done by us as the Android developer. And this is going to allow us to both iterate a lot faster on top of just getting back the exact data that we wanted in the first place. So hopefully that helps explain why GraphQL is important, what benefits we get out of using GraphQL. So now we can move into understanding it a little better. Many GraphQL APIs can ship with this open source web tool called GraphiQL. And it's this really great web tool where on the left, you can go ahead and enter some query that you want to write. On the right pane, you see that data response. And then all the way to the right, we even get a documentation explorer. This documentation explorer is great because all of the GraphQL APIs have their own schema that they work with. There are specific queries you can run. There are specific entities that are returned. And so you can look at that documentation to see, what are the queries I can run? What are the possible fields in my response objects? So let's click on that and actually look at some queries that we have here. So this open source Pokemon GraphQL API has two queries we can run. The first one, Pokemons, takes some integer, which is how many Pokemon you want, and it will return a list. The second one takes in Pokemon, is called Pokemon, and it takes in an ID or a name, and then it returns that specific Pokemon. Two syntax notes to get from here is this exclamation point indicates something is non-nullable. So for the Pokemons query, that first property is required. If you don't pass this, the query won't work. But if you notice in Pokemon, ID and name don't have exclamation points, which means you can really pass one or the other. So that's nice. And this also applies to the responses. So because neither of the responses have an exclamation point, that's an indicator that you're not guaranteed to get something back. If I send an invalid ID, maybe I shouldn't get a Pokemon back. So that's something to keep in mind. And then the brackets are just the array syntax, which is similar to some other languages. But I wanted to point that out. When we write these queries, I showed you before we just put the name and number of what we wanted, but that worked because those are strings. You can have nested objects inside your GraphQL entities, in which case you need to add another bracket and nest your query even deeper. Because I can't just request weight, which is a Pokemon dimension. I have to specify which properties from Pokemon dimension do I want. Here, that's minimum and maximum. So a good way to think about that is when you're writing your queries, you can only request like primitive types, strings, ints, booleans. But if you have something more complex, you're going to need to nest your query a little bit to request that detailed information. So that's an introduction of GraphQL, how to understand queries, how to use this cool web interface to test our queries, see responses, see documentation. And now that we understand GraphQL, we need to look at how do we use it on Android. Sorry, one moment. So on Android, we have this great library called Apollo GraphQL, which is a networking client for making GraphQL requests. You can think of this similarly to Retrofit. Many of us are probably familiar with Retrofit for hitting the APIs that we looked at in the beginning. Apollo is a new library to work with just GraphQL. And thank you to the admin for dropping all the links. That's very helpful. So with any new project or any new dependency, the first thing we need to do is add that dependency into our project, keeping in mind that Apollo Android is also a Gradle plugin. So we need to make sure we add some dependency into our project level build.gradle, and then inside our app, make sure we actually call apply plugin. Because Apollo is going to work doing some code generation at compile time, and we'll talk about that later. Once we've added the library, we need to create a GraphQL directory to point to all of our GraphQL files. And this directory lives inside the main folder. So you may be familiar with your projects doing source, main, Java, and then all of your package info inside of there. Right at the same level as that Java, we're going to create a new package called GraphQL. And then we're going to still add our package name. And then we're going to put a few files inside of here. And I'm going to walk through what each of those files are, starting with the schema.json file. Because GraphQL works with code generation. And I mentioned earlier that Apollo works with code generation. And I mentioned earlier that every GraphQL API has a predefined schema, specific queries you can write, specific responses that come back. And we can actually get all of that schema and store it in the app. And that way at compile time, we can make sure that the GraphQL queries we write for Apollo are valid. And to get that schema, we need to create something called an introspection query. And basically what the introspection query does is gives us metadata about our GraphQL schema. It will return all of the possible queries we can write and mutations. I don't talk about mutations in this talk, but you can think of those similar to a post request. A GraphQL query is when I want to just receive information from the API, but a mutation is to update. Say I want to tell the API to update a profile. That's what a mutation would be used for. It returns all of the models in a graph. So this will tell me Pokemon. This will tell me, the Pokemon dimension that we talked about earlier. And this footnote has a deep dive into these queries if you want to understand how they come together and what is actually being returned. But in this case, we actually get to do what all developers love to do, which is copy and paste. Because after a while, once you understand you need to run an introspection query to get your schema.json file, and you know that you just need to put it inside this GraphQL folder, you really don't need more than that. It just becomes a sort of copy-paste process to do that. So we can go into this blog post, get this really long introspection query that's in a gist at the bottom of the blog post, paste that into our web interface, and then on the right, we're going to get back the metadata about our schema. And then we're going to copy it. And then we're going to go into our IDE and paste that into a file called schema.json. And that's it. We don't need to read this file. We don't need to understand it line by line. We just need it there because that's going to be used by the Apollo library when it does its code generation. The Apollo Android library does have a Gradle task to fetch this and update it for you. I personally haven't tried it, which is why I left that method out of this talk. But it's something I would encourage you to look at and maybe consider just running that Gradle task every once in a while and make sure if your schema changes, your app is always going to be up to date. I'll leave that up to you. But the next file we need to add in here, or files, is all of the queries that we want to use in the app. And we can call these files, oh, got a little ahead of myself. We're going to talk about writing your queries. And we do that in any file that ends in .graphql. You can put them in one file. You can split them up into multiple files for different queries. But in my project, I created a Pokemon queries.graphql file. And this is going to go in the same directory as our schema.json file. And that's where we're going to write the queries that we want to use. So the syntax here is similar to what we looked at before, but just a little different. Like we need this query modifier in the front. We're going to name our query, called Pokemon query. We're going to define any arguments that our query takes in. In this case, we just have one called first, which is an int. And the exclamation point means it's non-nullable. And this is really helpful here. And we see this later in the talk that the Apollo Android library looks at these sort of nullable and non-nullable indicators when it does its code generation. And because first is non-nullable, when the code is generated, first is going to be listed as non-nullable in my generated query. Similarly, if it was null, the generated code would handle that. So if I'm using something like Kotlin, I will get that type safety all the way through. I'll know from my Kotlin code whether or not this is nullable. And then inside, we can name our response. Here I'm calling it Pokemon list. And then this is the actual query from the document inspector we looked at earlier, where I'm requesting the first number of Pokemon. And for each one, I want to get their name, their types, and their image. Once we've added our schema.json file, and we've added our Pokemon queries.graphql file, we can just run the Gradle build command. And when we do that, we'll notice that there were generated Java classes for our queries. So in this project I was working with, there were two queries. There was also a Pokemon detail query, which wasn't on the last slide. But you can see for each query I write, it's going to get its own generated Java class. And then we can talk about how to use those queries. So we're going to write a query from our code. This could be inside like a view model or your own repository class. There's a lot of code here. We're going to highlight it and step through line by line, don't worry. But we start by creating our query. So we can call Pokemon query.builder. This Pokemon query is the same thing that I named my query in the last slide. It's going to have a method for each argument that that query takes in. And then it's just going to call .build to get your Apollo query. Once you have that, you'll define a callback. This looks a lot like the retrofit callbacks. If you've worked with retrofit for networking before, and before you go and add RxJava call adapter or coroutine call adapters to retrofit, this is sort of callback that you may be familiar with, a method for onFailure and a method for onResponse. And inside onResponse, we'll be able to parse back all of the data that we wanted. So we call response.data.PokemonList. That was what I named my data response. And then for each item in that list, I'm just going to call the Apollo Pokemon.name, .types, .image methods. For each field that I requested in my GraphQL query, we're going to have a public method on the response to get that data. So that's what each of those three lines are doing. And then at the end, we take our Apollo client, which you didn't see created in this slide. We will look at that next. We're going to query the query we built in the beginning, and then onqueue a callback. So again, this may look very similar to retrofit when we first started using it. Next, I want to make sure we understand the generated code, not by looking at the generated code, but understanding what was generated and how that maps to the query we wrote in our .graphql file. So on the left is all of the code that we just looked at inside a repository or something. And on the right is the query from our Pokemon queries.graphql file. And so we see here the name of the class is whatever I named the query. And then the names of each method on the builder are going to be the names of each argument that I gave that query. So that's where Pokemon query and first come from. We mentioned naming the response Pokemon list. That's why we have a method on data called Pokemon list. And then for each field we requested, we're going to get a public method with the exact same name. So that's a helpful way to understand what you're writing in the GraphQL file and how that maps to the generated code, so you know how to use it. As far as creating our Apollo client, this also looks very similar to retrofit. Apollo also uses OkHttp under the hood, so we need to create an OkHttp client. And then from there, we create an Apollo client with some server URL. Here is the one to that open source Pokemon GraphQL API. We specify the HTTP client, and then we build it. One really nice thing about using HTTP under the hood is that if you are working on an app that is currently using retrofit and you want to migrate to GraphQL, which I talk about in depth later, you may already have your own HTTP client defined in your app, one that uses custom logging interceptors. Maybe it uses an interceptor to add authorization headers to every request. If you already have that code in your app, you won't need to rewrite it a second time. You can use that same HTTP client inside of your Apollo client. So we were able to do that at OkCupid when we first transitioned and found that really helpful, that we didn't have to rewrite any of the interceptors that we already had. And this is a great breaking point. There's still more to talk about, but everything we've talked about up to this point is everything you need to write your first GraphQL query. You understood why GraphQL was important, a little bit about how GraphQL syntax works, how to add the Apollo library, write and generate queries, and then use the Apollo client to make those queries. So this is a great way to say, like, in just about 20 minutes, we learned everything we needed to know to get started with GraphQL. And that's really great. There's not a large learning curve to get started. And now there's a lot more we can do, which is what the second half of the talk is about. But worth pointing out, like, that's enough to get started. We can take the code we wrote, run an app, see a list of Pokemon. So let's move on to how we can go even further with the Apollo library on top of what we've already done. The first option, which is my personal favorite, is inside our build.gradle file, we can configure the Apollo plugin to generate Kotlin models instead of Java. We all love Kotlin. It's 2020. No one's using Java anymore anyways. And this will make our query code a lot more modern. So instead of the builder pattern for Pokemon query, there will be a public constructor on the Pokemon query class, and then a constructor argument for each of the query arguments. So I just say Pokemon query first equals default limit. This is a lot more readable to me. And then below, when we're actually accessing our data responses, they will be accessed like fields and not public methods. Not a lot of difference here. This is just syntax sugar. But I'd also argue if you ever found yourself, and I rarely do, but found yourself in the position where you need to look at the generated code from Apollo, it's going to be a lot more easy to understand a Kotlin generated class than a Java generated class. So I recommend turning this on if you are using Kotlin. We can also use something called GraphQL fragments. And this is a hard one to talk about because we're all Android developers, so to us, fragments mean something entirely different. And so we're about to go into our code base and add some stuff with the word fragment that is not what you think it is. But a GraphQL fragment is a way of dealing with duplicated code. So here I have two queries, a Pokemon query and a Pokemon detail query. But if we look at the responses for both of them, they each request name, types, and image. And maybe that's because I want the same information displayed for a list of Pokemon as I do inside the Pokemon detail. And so if anything about my UI were to change, if I wanted to know like the Pokemon number, I would need to add that to both of these queries. And that little process can get tedious because I have to add it in 2 places. I have to find 2 places in my code where I'm making these queries and update those. And that's just a bit of a hassle, right? So we can use a fragment to share information. And the syntax for this is at the top. We use the fragment keyword. We give our fragment a name. Here it's Apollo Pokemon. We tell it on what entity we're making the fragment. Here it's the Pokemon entity from our GraphQL schema. And then each of the fields that we want inside that fragment. And then the syntax changes in our queries below, where we just put ... fragment name. And so for each of our queries, it's going to request the same pieces of information. If I want to now add the Pokemon number to these queries, I just have to add it to the fragment, and I don't need to change anything. Now, we're not limited to just the fragment here. If I wanted to add a new line below this to request what's in my fragment and then request some additional information for my specific query, that is supported by GraphQL. I made the mistake of not including that in my slides, but just know that that is possible. You're not limited to just requesting what's in the fragment. Next, I want to talk about migrating to GraphQL, because many of us as Android developers might be working on existing projects that are already using REST APIs. Or maybe you're working for a company that uses REST APIs and your company is switching to GraphQL for its backend, which is what happened to us at OkCupid. This is a big change. It's not really something you can do all at once. And so I want to share some tips and tricks that I learned along the way of moving from using Retrofit everywhere to instead using Apollo everywhere, and some tips that I think can make this process easier for you. A really common problem that we ran into in the beginning was this sort of concept where we're creating a view model and the view model takes in a REST API. And this is good, right, in that we have constructor injection. I can mock this API in my tests. But if we consider what the REST API was doing, typically using retrofit, returning our own model objects that we defined, but we now have an Apollo API that's using generated code. And so they're not returning the same data type, which makes this setup, as we have it right now, difficult to swap them. It's hard to just say, use the Apollo API, use the REST API, because their return types are a little different. So I really think before you migrate to GraphQL, you should leverage this idea of repository interfaces. Create some interface that defines the contract of the data you want. So here we have a getPokemonList function that returns a Pokemon list response, and a getPokemonDetail that takes in a Pokemon name and returns a Pokemon. And then our view model is going to take in an instance of this interface. And this is really great because now our view model is going to work sort of no matter what, and we can build our own implementations that will take whatever we're getting from the respective API and map it to that appropriate response. So again, multiple implementations are possible. We can create a retrofit service that is going to talk to our REST APIs, and an Apollo service that's going to talk to a GraphQL API for the Pokemon data. But each one has to abide by the contract that we've defined. And a benefit of this, beyond just being able to easily swap things out, is that we can now A/B test our new API if we want. We could say if they're in the test group for the GraphQL API, return the Apollo service. Otherwise, return the retrofit service. And you might be asking, well, why should I A/B test the new API? A/B tests are great for a lot of reasons, and we use them for experimenting with new features to see, does one perform better than the other? Do users actually enjoy this feature? But API changes aren't user-facing, so it might not seem like something you would want to A/B test. But one possible consideration is, if GraphQL is new to you, you can monitor performance of a page using the different APIs. you can make sure that the loading time for GraphQL users is just as fast as it was for the REST users. And if it's faster or if it's slower, you would want to know that. But this is also just a big change. You should ship with confidence. So for our company, GraphQL was kind of new to everybody. It wasn't used on the apps. It was new to the web team that does our APIs. And so we just want to have confidence that we didn't break anything. And we don't A/B test for every page, but it is helpful to do for the first time you use GraphQL, just to get that confidence. So about a year ago, when we started building the GraphQL backend at OkCupid, I took one page, our conversations page, and I used that repository interface setup that I mentioned, and I A/B tested using the GraphQL API. And we did this to make sure that the Apollo library worked great. We didn't see any decrease in loading times or usages or anything else. And so we were able to have confidence in GraphQL and in Apollo that when we started using GraphQL on new pages, we just shipped it out of the box. But keep in mind that doing this experiment up front can be really helpful to allow you to ship with that confidence. And there's also tips I want to give you for dealing with generated code. Generated code is hard to work with for a lot of reasons, but the main one is that it's not our code. We don't have control over what those GraphQL query classes are doing. We can't change them. And so we're just kind of forced to work with that, and that can be hard. And also, our repository, because this is something we've defined as returning classes that we care about, our repository doesn't return the generated code. And we do this for good reason, because we want our repository to return a contract that we manage. But that means somehow we need a way to map that generated code that Apollo creates into our data classes that we've defined. And that's where the Fragment stuff that I mentioned earlier comes back into play, because we can leverage Kotlin extension functions for things like this. So when I defined an Apollo Pokemon fragment, for all the base information I want for every Pokemon, the name, the types, the image, I can create an extension function on that generated class for the fragment that converts it to my Pokemon entity. You'll see we do that by just creating a Pokemon and setting each of its constructor parameters to the resolved value from the GraphQL API response. And so now, no matter where in my code that I use this Apollo Pokemon fragment, all of my individual queries will work and map to my new Pokemon automatically. And this also limits the places I have to change. Like if I change the Apollo Pokemon fragment, I just have to change this extension function, and everything else across the app should still continue to work. So this is more than just syntactic sugar. I think this is a really confident solution that limits the places you're changing things and also allows you to have confidence in the rest of the code at the same time. And beyond all of that confidence, it makes the parsing of the requests so much cleaner, because all of those lines requesting each of the individual properties from the GraphQL response are now shoved away in this extension function, so that when I'm mapping the response, I can just call my data. I have to call .fragments, which is what the Apollo Android library will do when you're requesting a fragment in your response. Reference the Apollo Pokemon, and then call my extension function. And so now this val is working with my data type, and now I can begin to do all of the things that I'm familiar with and that I wrote. And as we're starting to wrap up, I want to talk about different options we have for consuming Apollo API requests. The first one that we looked at earlier is something you may be familiar with when we looked at retrofit, and this callback approach of specifying what data I want back in the callback and either getting an on-failure or an on-response callback. And this is fine. This is what Apollo gives you out of the box. But the Android community in general is sort of moving away from the callback syntax. We're tired of, callback hell. And I can't return for my repository and on response. That's not how like asynchronous programming works. So I almost need some sort of more complex solution with this to get the response back. But thankfully, there's a few things built on top of Apollo we can work with. Like Apollo has another library or a separate artifact you can add for RxJava 2 support, where we create our query at the top. And then if we're using Kotlin, we have this extension function on our Apollo client called RxQuery, where we can make that query and then we're given back an observable that is still of the generated response type from Apollo, but now we have an observable where we can subscribe on whatever thread we want, observe on whatever thread we want. We could even use the map operator in Rx to map that response to my data type. And then when subscribe is done, I can call whatever I want on my data type. So this can be really helpful. If you're still using Java, you don't get this fancy RxQuery method, but there still is some static method you can call to convert from the Apollo query into an observable. And then if you're familiar with coroutines, there is an artifact that has support for that as well. So if you're inside a suspension function, for example, we can call Apollo client.query.toDeferred, which will give us a deferred of our generated response type, .await. There are some adapters in this library as well to take your Apollo query and convert it into a flow. But again, I personally am not familiar with Kotlin flows yet, so I've left that out of the presentation. But if you're familiar with flows, check out this link at the bottom, and you'll be able to understand how you can convert things to a flow and work with that as well. So those are the three options we have for consuming Apollo queries. Inside the Apollo Android GitHub repo, as many libraries do, they have sample apps. And I actually contributed to Apollo about a year ago when I started learning and contributed to the sample app 3 different types of repositories, one that show how to query Apollo using the callbacks, one using RxJava, one using coroutines. So check out the sample app inside their repo to understand how each of these work a little more. And that's the bulk of GraphQL and Apollo that I'm going to talk about. That is definitely the most technical portions, tips for migrating, different ways of consuming it. But I had one other sort of side thing to talk about that didn't really fit in with all of that. But one last small suggestion I want to leave you with, which is this really great IntelliJ plugin called JS GraphQL. And when you first start with Apollo and you build that .graphql file that we needed in the beginning, the IDE is probably going to prompt you and say plugins that support this file extension. And it's going to point you to this plugin, which is really great because it will give you auto-completion, error highlighting. It mentions this schema-aware development. So you tell the plugin where your schema.json file is, which gives you all of your metadata for the API. Admin is definitely on top of it. You tell the plugin where your schema is, and so as you write your queries, the plugin will be able to do auto-completion, error highlighting. You know, for an example, here it shows the auto-completion in action, but the schema file, one of the other metadata you get is like documentation. So this screenshot is really short. It can't fill out all of the evolution requirements. You see that ... But it shows the name of the field I want, the documentation of that property, and then like what its type is. So if you're not like super familiar with your API, if you don't know it inside and out, you can kind of do some code completion to guess and check at what's available. And you can also command click on these properties and see where it exists in your schema.json file to learn more. And you can also tell this plugin like what the endpoint is for your API so that you could run these queries right from your IDE. This one was easy to do because this is a public API, but you can also use this with a private API. You will just have to specify your own authorization token and such. But this shows me testing my queries right from inside the IDE and not inside the graphical web interface that we saw in the beginning. So it's a really small tool. It didn't play into the first portion of the conversations, but it's kind of a must-have for working with your GraphQL queries. And so that's the talk. The GitHub link at the top is to a sample app that is a bit complex because I mentioned it's my sandbox for a lot of things I'm learning. But inside that sample app, you can see GraphQL and retrofit code together. And you can even open the app, go to a settings page, toggle whether or not you want to use GraphQL, and then be able to debug and see how that code looks. Oh yeah, if an admin could share the feedback link, that would be great. But go ahead and enter some questions. I suppose people may be entering them right now, so I don't know if I should give people a moment or if I should answer the questions, and we'll see if more ones come in as we go. And admin, what do you think? Great. So do you know a GraphQL client that can be used in a Kotlin multi-platform module? I personally do not. I tried looking at this quite a while ago and wanted to try and do GraphQL on multi-platform and had trouble. I won't speak for them, but I have seen some buzz that the Apollo contributors are working on making Apollo 2.0 multi-platform compatible. I don't know what the roadmap is for Apollo 2.0. Oh, see, all right, so someone else was confirming that for me. I don't know what the roadmap is, like when that will be available, but that's what I would keep an eye on for. The next question is about who initiates the schema file. So it would be the backend team that's writing the GraphQL API. They would be responsible for defining all of the entities that are in our schema and all of the queries that are available. And once they've done that, anyone can run that introspection query I mentioned to get the data back, get the metadata back about what the schema provides. So the mobile developers aren't really writing the schema. All we're doing is getting a copy of it and pasting it into our app. It's possible you still need things changed about the API. Maybe I could request every field from Pokemon and I still don't have enough. Then your solutions are really to go to your API team and tell them that you need more fields. But some companies actually build a solution around GraphQL where anyone can contribute to the API. So there might even be a scenario where if you need an additional field added, maybe you could write some of the potentially JavaScript code on the back end to add that new property. I won't really go into all that, but typically it relies on the API developers if we need changes to the schema file. What about mutations, easy or hard? I would say from the front end, or rather the application developer standpoint, they're still very easy. The syntax inside we'll still write them inside our .graphql files, but instead of query, Pokemon query, we'll type like syntax mutation, Pokemon mutation. And then it will take in some fields, and we will put inside the request, I guess, what those fields are. And then the response that comes back from the server can sort of depend on the API. Like there's a little bit of differences, but I guess the reason I'm justifying easy is because at the end of the day, you change some syntax in your .graphql file, and on your Apollo client, you call the mutate method instead of query. But on your side, it's very similar, right? I make this request, I get some response back. I have to write a few different words to signify that this request is different than a query request, but it's the backend that is going to have to deal with the actual mutating and updating the database. From an Android client perspective, a lot of the code is going to look very similar. So I wouldn't say that mutations are any more difficult than making a query. Can we still use GraphQL in an API REST by passing the query as a parameter without using Apollo? I think that the short answer, there's a short answer and there's a long answer. I think the short answer is, from a technical standpoint, yes. When I was first evaluating GraphQL, there was some stuff I found out there where people were able to use it using retrofit. But I don't know if that's really easy or scalable. A lot of people do feel like Apollo is the client to use. It's definitely the one that I strongly recommend. I haven't really heard about one taking its place. So in a practical standpoint, I want to say no, but I'm also obligated as a presenter to say that from a technical standpoint, yes, but I wouldn't recommend it. Have you done some refactor from REST API to GraphQL? And have you seen some improvements? We did see some improvements with the GraphQL API, but there's some nuance in that like some of our REST APIs existed for a really long time. And so for a company that's existed for a long time, APIs can get bloated. People want new pieces of information, so responses can get bigger, maybe services get larger. But when we were building from GraphQL, we were really sort of building a new API from the bottom up. And so we were able to cut out a lot of, for lack of a better word, garbage that had been added to our APIs over the years. And so that helped make it a little faster. But I think strictly, like, one is not significantly faster than the other. But that nuance is something you might be able to see it faster if you're sort of building a new API from scratch. But in terms of the application client, you're still going to deal with networking latency. You're not going to see much of a difference there. It's whether or not your backend can make the GraphQL API faster. Business objects that are generated by the library are not parsable or serializable. It's not easy to pass them from one activity to another. What's your solution? So I'm actually curious if this question came in near the beginning or not, because my solution to this relies in the interface contracts and like taking your GraphQL response and mapping it to a data class that you create, either through extension functions or doing it right inside the API response. And then you can make your implementations parcelable or serializable to pass them around. So I hope that that answer makes sense. And I'm glad you all enjoyed the talk. I don't mean to be ignoring chat, focusing on questions, but I really appreciate all the kind words. I'm glad you all enjoyed this. So could GraphQL be a better replacement for a conventional API development used for multi-platforms? Are there any limitations? So we were able to talk about multi-platform, which is great. I think it is a better replacement because of the fact that it is client-side, because we as developers can choose what information we want. We can change queries as we want them. So in a typical sort of work environment, if a product manager comes to you and says, oh, we need this additional field on the profile page, I can just go into my GraphQL query and add that field and get it to show up. I don't need to go through the feedback loop of working with another developer. And then we also have those data science concerns in general. Like even web teams using the REST APIs have to request either all of the information, which could be too much or too little for web pages. But everyone wins with GraphQL because you get exactly what you ask for. And I think that's way better than conventional API development, where the API gives you some specific stuff, and you have to choose whether or not it's good enough. Would you recommend using the Apollo library's cache mechanism? I am not strictly familiar with the caching in Apollo. I would suggest you treat this question with the same sort of research as any other caching efforts you may do. So consider how often you expect that data to change on the back end. If the answer is very often, maybe this is a sort of query or response you don't want to cache. If you don't think it will change often, then yeah, I think you can leverage the caching inside Apollo or your own caching mechanism to limit that data. I personally don't know enough about what Apollo's caching is doing under the hood to speak for that library specifically, but I do recommend looking at this question the same way you would look at any other caching concerns and ask yourself, do you feel comfortable caching the data? Are you worried about it becoming out of sync? And depending on that answer, use that to decide whether or not you should ask Apollo to cache things. Do you have any best case example to use GraphQL? This is a good question. It's hard to say a best case without repeating the talking points about only getting the data you asked for. And so if you consider the Pokemon API from the very beginning, the REST API, I love PokeAPI.co. It's very thorough. It tells you everything you want to know. But I also thought it highlighted the flaws in REST, and that we saw from the Pokemon list sample, we got no information. We only got the Pokemon's name. But when we look at the detail sample, we got way too much information. We got 11,000 lines of JSON. And so I think that's a really good example of using GraphQL. It's like a REST API can have two really large extremes of not having nearly enough data to populate a UI or having way too much data. And so that's where GraphQL comes in, is that we are able to get exactly what we want. So this is a good question. In fragment creation, what is the part on Pokemon used for? This was a tricky thing to explain strictly in words because it ties into our GraphQL schema. So inside the GraphQL schema, we have all of the queries defined and we have all of the entities defined. And in this case, Pokemon is an entity in our GraphQL schema. Like the Pokemon query returns a Pokemon object. And so I'm saying I want a fragment on that Pokemon entity. And so I can only use that fragment in queries that are returning the Pokemon entity, which is why inside the fragment, I'm able to request things like name, types, image. It is something that sort of takes a little bit of getting used to. I hope that clears it up. If I didn't, please shoot me a direct message in Slack or on Twitter, and I'm happy to dive more into fragments with you. Do you personally prefer Insomnia or Postman to play with requests? So personally, I've never used Insomnia. So between these two, I feel like I have to pick Postman. I would check if the GraphQL API you're working with supports the public GraphiQL Interface. Because I like that a lot. You paste code on the left, you press the run button, you get the response, it's all right there. I find that really helpful. But I don't know, I feel like this can go into personal preference. Like I really like the graphical interface because I can type on the left, get code completion, see my response on the right, also dig into the documentation all in one go. I don't know if with Postman I would be able to see documentation about my specific schema. But it sounds like we're entering the territory of finding what works for you. If you've been using Postman for REST APIs for a while, and that's what you're really familiar with, then maybe that's something you should stick with if that's what you know. And this is a great question to end with at the end. What is your favorite Pokemon? It's definitely Squirtle. Like, favorite waters type, had to start with him when I got the first game. Love Squirtle. So, great. Are there any, I think an admin told me, correct me if I'm wrong, no one's here right after me. But if there are any other burning questions, I'm happy to take them. Otherwise, we'll wrap up here. All right. Well, I didn't see any other questions come up, so I will be active in Slack if there are other questions. I'm glad you all enjoyed it. Thanks for watching.